What I want to talk about in this episode of Feature Fundamentals are JavaScript functions. So JavaScript functions are another one of these elemental kind of building blocks or fundamental building blocks of the JavaScript language. And this is technically true of any programming language, but because we're talking about JavaScript here, we're going to say that functions are a fundamental feature, a fundamental element of the JavaScript language. So what I want to do in this video is talk about what functions are and what they're actually made of, so what the different parts are, as well as the different ways to define them, and then look at some just basic application of them. So there's a lot of terminology that can get passed around when you're working with functions that honestly can get kind of confusing, especially if you're a beginner. So what we're going to do to get started is just take a look at a very simple example. So here I've got this function that I'm defining using the function keyword. So I've got a function called add. So what I'm going to do here is, if you didn't watch any of the earlier Feature Fundamentals videos, what I'm doing here is kind of walking you through the blog post in like an interactive way. So I decided that this is kind of a fun way to do it because it'll give you a reference in text that you can kind of copy and paste from later and go back to without having to go through the entire video, but it also kind of helps me out because it gives me a little bit of a script, so I make sure that I don't miss anything while I'm explaining this to you. So what we're going to do is we're going to take this little snippet right here. So I'm going to copy this, and I'm using a tool called CodePen. So if you go to codepen.io, this allows you to get access to what's known as a REPL. So this is an environment where you can run code automatically in your web browser without having to have a specific environment. So you don't have to do something like this. So you don't have to open up your browser console to run some code, and you don't have to, if you're using a technology like Node.js, you don't have to run a Node.js server or interpret code in that environment. So basically it just allows us to start writing code, get a result, and see what it's going to do. So we're going to go ahead and paste this function over here. And now right now, when we define a function, we're not actually doing anything with it. So as far as JavaScript is concerned, this function exists in memory, but it's not being called, and so we'll notice that nothing really happens. So what we're going to do is we're going to call this. We're going to say console.log, and what this is going to do is this is going to print a message down here for us. And the message we want it to print is the result of calling our add function. So we can see here that we've got number 1 and number 2, and then we're saying number 1 plus number 2. So we can kind of take a guess about what this is going to do. So we're going to say 1 and 3. And we'll notice that the first time, what's nice about CodePen is it evaluates your code in real time. So the first time I passed 1, it evaluated it because I hadn't passed 3 yet. And we're going to talk about this NAM symbol in a little bit. But notice that when I call add with 1 and 3, we get back 4. So we're logging out the result of calling add with 1 and 3, which is pretty cool. So that is the basics of a function. That is a function. But that's not terribly helpful. So we get into the situation where we're trying to figure out, like, well, what is a function, though? Like, what are the different parts? And so this whole thing is known as the function signature. So just like you or I, if we go to sign a piece of paper, we'll put our signature on the paper. If we sign a receipt, we'll put our signature on the receipt. In the very same way, when we define a function, we're technically signing this function, if you want to follow the metaphor, into our JavaScript file or into our JavaScript code. Kind of a weird name, but I really like it. I don't know why. It's not a direct metaphor, but you know, it's fun. It sounds kind of cool. So a function signature describes all this stuff, but there's a lot of different parts that make that up. So the signature is all of this stuff. So it's the function keyword. It's the name of our function. So here this is called add. It's the arguments or inputs of our function. So here we've got 2 arguments, number 1 and number 2. It's the function body. So it's the actual code that makes up our function and does our work for us. It's the return value of our function. So it's number 1 plus number 2 and how this actually gets evaluated and returned. So all of this stuff is referring to the function signature. And so what we're going to do now is actually break down those different parts, because even if you understand that this is a function, You may not know why to use that style because you may have come across different styles of functions, and we're going to talk about those. But you may not know, like, well, what's the application here? What is all of this stuff? And so when you're reading different tutorials online, or if you're watching another video on the Clever Beagle channel and you see some of this stuff and you're like, wait a minute, what is that? Hopefully this is going to help. So the first thing I want to talk about is this idea of arguments. And arguments sound honestly kind of negative. They don't sound very helpful, but they are. They're actually a positive thing. So when we talk about arguments, what we're doing is we're talking about everything that we pass, and you'll hear that term pass quite a bit, everything that we pass between these two parentheses here. So you can see here we have two arguments. We have an argument called number1, and we have an argument called number2. And now technically we can add as many of these as we want. So we can say number3, number 4, number 5. But you'll notice that over time, this gets a little cumbersome. So one of the things I do recommend, and I want to recommend this early on if you're just learning JavaScript, is to limit this to 3. So we'll notice that it just looks a little overwhelming, and it can start to get confusing, especially when our function isn't as simple as this, where it's just adding 2 numbers. If we have multiple lines of code and we have all of these arguments, it can just be a lot for your brain to process. So one of my personal rules of thumb is to limit your arguments to 3. So keep it down to 3 if you can. And then in situations where you need to pass more than 3 for some reason, what you can do is store those values inside of a JavaScript object. So one of these will say, I don't know, we'll say turkey. Actually, we're not going to say turkey. I love saying turkey. So we're going to say sandwich, and we'll say bread is rye, and we'll say meat is, there you go. Now you get your turkey. We'll get vegetables, so we'll do that as an array. So we'll say a tomato and some lettuce, and then we'll say condiments. What do I like? I like mustard, so we'll put mustard on there. So the point I'm making here is that in this case, if we had, let's change this to make sandwich. If we wanted to pass all this stuff, so we'd have to do something like bread, and then we'd have to do meat, and then we'd have to do vegetables, if I can spell it out. There we go. And then we'd have to do condiments. So we can start to see it gets a little unwieldy. This is a pretty simple example, but the point hopefully gets across. So instead of having to do this, which is also cumbersome on us as the developers because we have to write all this out, instead we could just do this. We could just say, okay, cool, we're just going to pass what we're going to call a sandwich, and then if we want to kind of add all this together, we could say something like sandwich.bread plus, let's bring that back. So sandwich.bread plus sandwich.meat, and so on. So we can reference the values here, but you'll notice that it cleans up the function signature quite a bit because we're only passing one thing, even though that one thing has multiple properties on it, which is pretty nice. So backing this up a little bit, one other thing to call out here when it comes to arguments is that arguments can technically be any name. So if I write this again, we're going to say 1 and 3. Let's get rid of number 3. There we go. So if we have number 1 and number 2, in this case, number 1 is whatever we pass here. So this idea of position is really important. So I have number 1 here, and so internally, and pay attention to that word internally, meaning inside of this function or inside of this function body, I'm going to be referencing 1 as the first number that I'm passing. So just to make sure that's clear, I could pass 5 here, and that's perfectly fine too. So it's not about literally the number 1. It's just this is the first number that we're passing into our function as an argument. And then the second argument we're referring as number 2. So here we've got 3, and I'm trying to not confuse myself as I'm explaining this. So we've got 3 as a number, and we're calling it number 2. So the point I want to make here is that these names for our arguments can be whatever we want. So we could call this pizza for number 1 and salad, and then do this. Let's say pizza plus salad. Oh, we've still got this called make sandwich, so let's clean that up. So we're going to say add, and then we're going to say console.log, just make sure we can see it down below. So if we do this, you'll notice that 8 spits out. So even though it's a little kind of confusing that we're calling them pizza and salad internally, we still get the same result. So the point here is that we can call these literally anything we want, and this will still work. Obviously, we want to call something what it is, and so that's actually an important tip. So something you might see in somebody's code, you might see like N1, N2, but you'll notice when I first wrote this out, I instinctively wrote number 1, number 2. So I actually spelled it out for you. I didn't just call it this random thing. I found personally, and again, this is just my opinion, and this is something I do in my own code. It doesn't mean you have to do it, but I've found that giving things an explicit name as to what they are, so not trying to reduce the number of characters just to save a little bit of space, makes a huge difference later when it comes to maintaining your code. So a lot of developers, including myself, love to write code the first time around. It's a lot of fun, and you can be really creative with it. But eventually, especially as you start to develop your own software with JavaScript, you're going to get to a point where, okay, you're going to have to come back and maintain that code, meaning you might need to improve the performance of it, or you might need to fix a bug with it. So something went wrong with it and you need to correct it. All of these little details start to add up. So whenever I have to ask, like, wait a minute, what is N1, N2? I'm wasting my time. And the thing is that time compounds. So right here in this trivial example, you're like, well, that's not that big a deal. But in reality, when you start building really, really big JavaScript programs, you're going to get into a situation where all of these little things that you have to think about add up. Whereas here, my brain can very quickly understand, oh, okay, we're adding number 1 plus number 2. Got it. There's no confusion there or room for me to get confused. So that's one little tip. Now, we talked about changing the name of our arguments here, but what we haven't discussed is the significance of position. So up until now, we're just saying 5 and 3. But where this can get kind of confusing, we're gonna jump back over here to the post, and we're gonna kind of read through this one. Hopefully this will make some sense. So if we get into this situation, and actually my example here isn't that great, I'm realizing now, and that's the kind of the benefit of hindsight here when we're doing this. So we have this function, and let's try and make this work. I'm gonna see what I can do here. So I'm gonna define 2 functions. Now I'll correct this in the post later. So we've got this idea of a cutting tool. So I'm gonna say scissors and item to cut, and then what can we do here? So we're gonna say, oh, I don't know. We'll take item to cut. Now, don't be too scared for this. This is just me making a point. This isn't something that we're going to really talk about right now. So if you're curious, this 3 dots is known as spread syntax. So that spreads something out. And we're going to ignore that for now, but it'll help me get this point across. So what we're going to do is we're going to call this cut item function here. So we've got cut item, and we can see that it takes 2 arguments. It takes item to cut and cutting tool. So in our case, we're going to pass paper, and then the cutting tool is going to be scissors. So this function. And so notice what cut item is trying to do is it's saying, okay, you want me to cut, so this item to cut, which maps to paper, you want me to cut that item using this cutting tool or scissors. And so if we look inside of this function, what we're doing is we're saying, okay, we expect cutting tool to be a function that we can call, and we can pass it a piece of paper. So here we've got cutting tool being called internally. Now, we don't know what cutting tool is. We're just making the assumption that it's a cutting tool. So we're saying, pass us a cutting tool, and we'll pass it item to cut. Now, in this case right here with this example, we can see that, okay, we are actually passing in things in what we'd call the correct order. So let's see if this gets resolved. I think it might. Yeah, nice. So here, what we're doing is we're effectively saying, okay, with the scissors, we want to cut something up. So we want to cut this paper up, and we can see here that I've cut it up into individual pieces. So we've kind of created some shreds of paper, which is pretty neat. So that works here, but let's see what happens if we say, okay, instead of putting paper first, we're going to put scissors first, and then we're going to pass paper as the second value. And then we'll see what happens. Well, nothing happens, but if we go ahead and say inspect here, open up a console, we're going to say cutting tool is not a function. We're not going to say that. JavaScript is going to say that. So we tried to evaluate this code, and it's like, wait a minute, cutting tool is not a function. So the problem here is not just a logical one. So obviously we can't cut scissors with paper. but also an actual programming error. So we have this problem of, okay, well, we expect cutting tool here to represent a function, and we expect this to be something that we can cut. So the point being made here is that order is very significant when it comes to your arguments. So if we pass paper here and then scissors over here, well, we get exactly what we'd expect. So we get back our cut up piece of paper. Now that's great, but notice that in order for that to work, item to cut, paper has to be first, cutting tool, the function, needs to be second. So that's it. So when it comes to your arguments, make sure that you're paying very close attention to the order. And if you're getting results that you wouldn't expect necessarily, make sure that you're keeping this in mind, because it may just be that you did pass something, but you passed it in the wrong order. And so it's kind of creating a weird result and not getting you what you expect. So next thing I want to talk about is default arguments. So we've talked about, okay, order is important and we can call them whatever we want, but this idea of, well, what happens when we don't pass things correctly? So we're going to go ahead and delete that and bring back our add function here. And so in this situation, let's see what happens. So we're just going to say console.log. We're going to call add with nothing. And we can see, and remember earlier I kind of hinted at this, so we had this NaN. That stands for not a number. So this is a global value in JavaScript that's returned when, and the way I kind of explain this is the computer, this is JavaScript essentially saying does not compute. So this just does not work in the way that, well, we'd expect it to. So here we expect it to add two things together, but in this example, we're not actually passing anything in. So there's literally nothing to add together. And so what we can do is use default arguments. So what I'm going to say is up here, I'm going to say number 1 equals 0, number 2 equals 0. Now, if we watch, what happens is we change from NaN, or not a number, to 0. And the reason why is that what happened was JavaScript evaluated this function, and it said, okay, let me call add. And so it's saying, okay, I expect an argument here for number 1, but you know what? There isn't one, so let me go ahead and set it to a default of 0. And then in the same way, number 2, you know what? Number 2 wasn't passed either, so let me set it to its default. And so what ends up happening is our code gets evaluated like we'd expect. We get 0 plus 0, and then we get our result of 0. So the reason this is important and why you would want to use default values is that, generally speaking, functions are not called in isolation by themselves, meaning we're not just going to call a function, get the result from that function, and then be done with it. Typically, what's going to happen is you're going to write some code that calls multiple functions in order or in a series of steps, and each successive function that you call might depend on the response from another function. So in our case, if we were to get rid of our defaults here, and we wanted to, call add, and then we wanted to call another function that depended on that result of add, well, if the response is not a number, but the next function expects a number, we're going to be in trouble, because now it's going to break that code. And this kind of cascades down. So it's once one thing breaks, then everything breaks. And so by using defaults, what we can achieve is making sure that, well, even if we don't get the exact result that we want, we can write code that's a little more resilient to problems and errors and make it do something correct. So in this case, we expect a number to be returned. And in this case, we do get a number back, even if you don't pass anything in, which is good. That means that the intended behavior worked, though we've obviously got a problem in our code and say, oh, you know what, we forgot to pass stuff. So if I pass 5 and 10, well, now we should get back 15. So there you go. So now, and let's just try this out. So we're going to say 5, and we should expect this to be 5 plus 0. So we would get 5 back. And so that's the nice part about this, is we can prevent ourselves from causing some really nasty messes without, running into any problems. So now what we need to talk about, now that we understand like the basics of what a function is and how it works, now we need to talk about the different ways to actually define a function. And so this is where, especially as a beginner, it can get kind of confusing. So what I want to do is take this function here. So we've got make a sandwich. We missed our F. Function. There we go. So we've got this function make sandwich. I'm going to go and clear that out. And so what we want to be able to do is pass in some bread and some ingredients and get these back. So what we're doing here is string concatenation. So if we do this real quick, so we'll say, oh, I don't know. What did we say earlier? We said rye bread. So we'll say sandwich, make sandwich. And we'll say rye bread is our bread. And then our ingredients. So here I know this because I can see here that I'm using this .join method, which tells me that I expect ingredients to be an array. So if you've never seen an array is where you have two square brackets and then some values. So here you can see that we get rye because we've got bread here and bread here, but we haven't actually passed any ingredients. Our array is empty, so we just get rye plus rye. Now, if I come in here and we'll say lettuce, tomato, I really like pickles. So now we're seeing we get rye, lettuce, tomato, pickle, rye. So we're making an actual sandwich, so that's pretty cool. Now, the way that we define this function is using this function keyword. So this you may have seen. This is, I don't want to say it's becoming less popular. It's still a valid way to define functions, but you may not see it as much. And we're going to talk about why in just a sec. But the important thing to point out here is what this function is doing or why we named it how we did or how we defined it how we did. So I kind of gave you a hint there. So what I'm going to do is I'm going to comment that out for a second. So what we'll notice is that we're saying function, some name, then our arguments, then our actual function body. Now, I can define this in another way. So I can say const make sandwich is equal to function bread. And you know what? I'm going to be lazy here. So I'm going to copy this part and then just paste it down. There we go. So then what I'm going to do is comment this out. And what I want to show you is how this works. So we're going to say console.log make sandwich. And we can see that we get the exact same response. So this console up here is the CodePen console, but it's technically mimicking what the browser console does down here. So don't let that confuse you. So we get the same exact result as defining our function like this. But notice that we've moved the name. So the name is now our variable. And then here we're defining the function by itself. So what's going on here is this is the separation between what's called a named function and an anonymous function. So here, let's uncomment this just so we can see all of it. So we've got make sandwich is a name. It's explicit. So we're saying this function is called make sandwich and it does this. Here we're saying, well, make sandwich is this function that does this. So this is anonymous because we don't know that there's a name here. There is no name here. We're referencing it via a variable as opposed to actually having the function name right here called make sandwich. And so the difference here, the reason you would do this really depends on what problem you're trying to solve. But ultimately, when you're using the function keyword to define your functions, it's good to use a name because what's happening here is essentially, even though JavaScript sees this code right here, our anonymous function, as a function in memory, it's just a function in memory. It doesn't actually have a name as far as JavaScript's concerned. And this can become a problem because of a lot of different things. So at least here, you can see that we're getting an error. We're getting uncaught syntax error identifier make sandwich has already been declared. So that's because we're defining the same thing twice. Now, this is pretty contrived because we're just doing a quick sample here, but you can run into situations where if you define an anonymous function like this, and then you try and reference it somewhere else, or you define another function called make sandwich somewhere else for some reason, you're going to run into a situation where you have collisions and you can cause all these bugs. Whereas when we do it with a name, we're being very explicit about what this thing is. And as far as JavaScript is concerned internally, meaning JavaScript evaluating our code, it's going to know exactly what we're referencing every time without a lot of confusion. So while these are functionally equivalent, meaning the thing that they do is exactly the same, the way that they're referenced internally in memory is a little bit different. And so let's see here. So I'm going to back that up. And then we're going to say make sandwich here. See if it'll let us get away with this. Yeah. So notice that we can put a named function behind a variable just like we could where we just had the function stand alone. So this is a great pattern to use, especially when you want to reuse the result of a function, or you want to call a function multiple times. So if you don't want to just have it by itself, you can put it behind a variable. And there's a lot of different reasons to do this that we're not really going to get into here because it depends on the type of program. But I don't know, maybe, we have Subway. So there's a chain of sandwich restaurants here in the U.S. And I'm guessing this is pretty international at this point. But you have Subway sandwiches and what's another one? I'm running out of sandwich places. There you go. There's one called Jersey Mike's. So both of these are making sandwiches, but we're going to give them different names. So there's reasons that you do this, but again, it's kind of esoteric and a little confusing, and so we're going to skip that for now. So the point being here that's the difference between a named function and an anonymous function. And then in terms of how to use it or what to use, generally speaking, I would say the best rule of thumb is to just use a named function, because then that way you're going to avoid a lot of weird little bugs that are honestly kind of hard to solve and hard to track down, especially when you're doing this inside of a larger program. So that is using the function keyword, but there's this whole other thing now called an arrow function. So if you've been reading about JavaScript or looking at examples of code, you may have seen something like this. So I'm going to go ahead and snag this code. And so this looks very similar to what we saw earlier. So let me write that out. So earlier we had function number 1, number 2, and then we had our code, and then we had return number 1 plus number 2. So technically speaking, as of right now, this code is equivalent. We're doing the exact same thing with both of these, and they're going to work in the exact same way. Now, they're not below because I'm not keeping the names unique. So let's say add 1, 3, just to make this clear. So I'm going to comment out the arrow one. And so we get 4. And then if I comment out the function keyword 1, and we go back to the arrow function, we get 4 as well. So they do the exact same thing. Now, there's some nuances here and why they're not exactly the same. So let's talk about that. So the first thing to pay attention to, obviously, and this is where the arrow name comes from, is that we define our function instead of just saying our arguments within parentheses and then curly braces, we add this arrow in here. So this is just a syntactic feature. This is meaning how we write the code. This is just stylistic. This is just one way to do it. Now, this tells us that our code is going to do something specific, which we're going to cover in a second, but stylistically, that's the only real difference between these two, is that we've dropped this function keyword in favor of just using an arrow, and now that tells us, okay, this is a function, but we're not having to explicitly state function. So that's one big difference between these two. Another one, and this is honestly one of my favorite features of what you would call, I guess, modern JavaScript or new JavaScript. So basically everything that's been added to the language since about 2015 or so. And that is this idea of an implicit return. So here we've got all this code, and again, these are identical in terms of behavior. But one of the nice things about arrow functions is you can say this. And so what ends up happening here is this code, and you'll notice, is evaluated in the same exact way. So we get a 4 back. And you may look at that and be like, well, wait a minute, how did that work? And that's because when we're using an arrow function, if all we're going to do is return a value, so we're not going to do any extra work. So what I mean by extra work is we might do something like this, like we'll create another variable here called new number, and then we'll say number 1 plus number 2, and then return new number. So here, technically speaking, this function now is doing 2 things as opposed to 1 in the form of a single return. So if our code is like this, meaning it's only doing one thing, all it's doing is returning a value, it's not doing anything else, no other computation, nothing, then we can use an implicit return. And that means that we get to drop that return keyword, and we can just put whatever code we want to evaluate immediately after the arrow. And you can notice we also lose the curly braces too. So this is really, really nice when it comes to writing cleaner code or just tidier code that takes up less space. And so if you ever hear that phrase implicit return, or you see code like this, that's what's going on. This code here is identical in terms of behavior to this code, and we can prove it. So let me do this, and let me see if I can get this to rerun as is. There we go. Okay, so that gives us 4, and then we're going to comment, and then we're going to turn this back on, and and we get 4. And so they're exactly the same in terms of the behavior. It's just the way that we've syntactically written them is different. And so this can save you a little bit of a headache in terms of having to type out extra stuff. And again, as you start to write bigger and bigger programs, you're going to run into this situation where honestly, it actually helps. So it doesn't look like it here, but not having to write all this stuff out every single time is very, very helpful, and it'll save you some headaches. So that's one feature, is this implicit return that's different about the arrow function. So let's go ahead and comment this. And then another one I want to show you, and this is very specific, but we're going to say, and see if we can get away with this. We're going to say alert, and I'm going to say hello. Oh, see, now it's good. Uh-oh. All right, we got to comment this. Otherwise, I'm going to get myself into trouble here. So we're going to say hello, comma, space, and then we're going to say plus name. So now here we had 2 arguments, but if we have 1, so we can write our code like this. That's perfectly fine. Or, and let's just change this just so we don't get confused here. So we'll say hello. So we'll have say hello, and then we'll call say hello down here. So we can write our code like this, and this should work just fine. So let's go ahead and just say hello. Okay, so it says hello 1. Let's actually pass a name. So we're going to say, well, we'll say my name. So we'll say hello, Ryan. So we say hello, Ryan. So because what we're doing here is we're saying, well, we want to alert this hello string plus a name. So we're going to do some concatenation here. Well, that makes sense. But one of the neat things that we can do is when we're only passing 1 argument to an arrow function, I have to really stress this. This is for arrow functions only. But whenever we're using this arrow function syntax, if we really want, we can just drop those parentheses around it. So we get the same exact result, except now our code is a little cleaner. We have a less stuff to look at and less stuff to type. Now, I would say as a beginner, that's probably insanely confusing and not the most fun thing to deal with. So I would say generally while you're learning this stuff, it is good to keep parentheses, but in some tutorials and some code, you might see those parentheses omitted, and that's what's going on here. So basically, that's just an author trying to save space. That's not something that you have to do or that's going to necessarily get you some additional functionality. It's just a way to tidy up code. So the next thing we're going to talk about, and I'm going to kind of breeze through this because this is actually, it's a much bigger topic, and it's something that honestly deserves its own article, its own video, because it can be really confusing. But it's this concept of this. So when you're dealing with JavaScript and functions, you're going to see the word this used quite a bit. So what we're going to do is we're going to copy this. And this is the, see, I keep saying this and now it gets really confusing. And this is the, I should just stop talking and then maybe this will make some sense. See, you can't talk without saying this. It's ridiculous. So a quick explanation here is that here we have a named function called make kid. So one of the things I want to do, I'd like to be a dad someday. So if I'm going to make a kid, well, they're going to have to take my last name at some point. So what I'm doing here is I'm saying, okay, we have our named function make kid, and that takes in a first name argument. And then we'll notice that inside of that function, we're saying this.last name equals my last name, Glover. And then we're returning the first name that was passed in plus a space plus whatever is assigned to this.last name. So this keyword here that I have highlighted changes based on the way that you either use a function or the function itself, like the format that you're using. So meaning a named function using the function keyword versus an arrow function. It can change, which is kind of confusing. So literally, like if we're saying this, our instinct tells us that this is referring to, well, this, the function. It's this thing we're currently looking at. However, we'll notice that down here, and let's see if I'm going to put a space in here so we can run this again. So notice that I get 2 responses back here. So I'm saying, and this is expected, so don't be too confused. So we're saying console log this value and this value. Now, we call make kid and it says Marcus Glover, and that's what we'd expect. We're saying first name plus space plus last name. And so we get a string back that says Marcus Glover. Okay, that makes sense. But then notice that this.last name is available to this console log statement, even though this.last name was assigned internally with this function. So what's going on here is this question of scope. So Scope refers to what this actually refers to. What are we pointing at? And in this case, what's happening is this is referring to this file. So if we think about like the edges of this box, we're technically evaluating a JavaScript file. So this is referring to the JavaScript file, and that's expected. So when you're using a function like this, so using the function keyword, this is automatically assigned up to the parent scope, or the file where this is being executed, or the parent function, if that were the case. So if we had, this is probably going to be a terrible example, but so we'll say make family. So in here, now this dot last name is being assigned to make family. So it's the next level up. So here's one level, and then we go out, and here's the next level. And so that's what's going on there. So again, that can be confusing because it looks like we're saying, well, assign last name to this function, but in reality, we're not. We're assigning it to the window or to the file that we're evaluating this in. So that's one way that this comes into the equation. The other is when and how we use an arrow function. So I'm going to skip over this. If you're curious about another way to deal with this, again, I think I'm going to write another tutorial on this because it is confusing. So what I would say is if you're interested in another way that this plays into using the function keyword syntax here, definitely take a look at this article. So this is cleverbeagle.com/blog/articles, and then what is a JavaScript function. I'll link this up down below in the video, but go ahead and take a look at it there. So the other thing I want to jump to is the scope of this in an arrow function. And this is actually very similar to what we just looked at. So if I go ahead and copy this, see, you can't avoid it. It's unescapable. We're going to say that, and then let me do this so it evaluates. There it goes. Okay, so now in this case, what's weird about this one is, well, look at our function. So we've got const make kid. We still taking a first name. We're still concatenating first name with a blank space and this dot last name. But think about this. This dot last name is defined outside of our function. Yet if we see, so we say, go ahead and log the call to that function, we're still getting back Marcus Glover. So what's interesting is that this here is not referring to our function, but it's referring to the parent scope. And so we're actually getting back to this dot last name here. So even though we're not defining it in here, again, what's happening is the scope is being bumped up to here. And so with arrow functions, this is always the case unless we manually override this in some way. Again, that's another advanced topic, so we're not going to talk about it now, but in 99% of cases, and unless you're explicitly doing this, what's happening is when you use an arrow function, you're automatically assigning the scope of the this value inside of that function to its parent scope. And it's always going to be the parent scope. So no matter what you do here, so just writing your code like this, it's always going to bump up to the parent level. So that's why we can get to this value here. Again, I'm gonna explain this in another video because it honestly even confuses me, and it's one of those things that even as an experienced JavaScript programmer, like I've been seriously working with it for about 6 years now, and I still get confused by this, and it's one of those things you just have kind of like a tacit memory of. You know how to use it, but the why is kind of confusing, and it still trips me up. So just to help me out and to help you out, I think we will do this in another video. So that's a brief explanation of this, but I think it's warranted to help you kind of understand this stuff. So one of the last things I want to talk about is this concept of methods. So I'm going to go ahead and copy this, and we're going to pull this over. And we can see here that what we've done is we've written an object. So technically we've written a variable or declared a variable. So we've got const calculator, and we're setting that equal to an object. So an object in JavaScript, again, like we saw earlier, I think we had something like sandwich, something or other, and we had multiple properties on that object. So we had a bread property assigned to something. We had condiments. We had a bunch of stuff on there. So that's an object. So whenever you see the curly braces like this, so, and I have to be very clear here. So we have curly braces here, and we have curly braces here, but it's two different things. So don't get confused by that. So you have curly braces here, and then you're assigning, and you use this syntax. So you say some name, colon, and then you'll give it a value. So he'll say bread, rye. So we're saying it's a string called rye, and then condiments we assign to an array. So we've got our property name here followed by a colon to say, okay, we're going to assign this property to this value. So that's what's going on there. Whereas up here, this is just saying, okay, this is our function body. That's not doing anything other than that. So don't get confused by that. So we have this object calculator, but then on that object, what we're doing is we're saying, define a property called add, define a property called subtract, and assign each to a function. So here we're defining add as a property on calculator, but we're assigning its value to a function. And in the same way, we're defining a property called subtract on the calculator object, but we're assigning it to a function. So what this does, and this is something that you'll see pretty often in JavaScript, is this allows us to call our functions like this. So now we can say calculator.add 1 and 3. And what we see is it works like we'd expect. So just like we saw when add was defined by itself, now we're just referencing it through or via this calculator object. So we have this object and we're saying, okay, calculator.add, and the dot is what tells us that we're calling to a property on that object. So in the same way, and let's see if this will work. So I'm going to say console.log calculator.add without calling it, and you'll notice that what it does is it returns the function definition. So I can still point to that function without calling it, and when I say calling it, what I mean is adding parentheses on the end and then passing in our arguments, so number 1 and number 2, in which we get back 4. So subtract works in the same way. So if I pass subtract here, we get -2 because we're subtracting 3 from 1. And so why do this? What's the point of this? So the point of this is mostly for organizational sake. So you get into the situation once your program gets to a certain size where you're going to have functionality that's related or that's a part of a group. And so in this case, adding and subtracting are forms of calculation. So we're trying to calculate numbers. And so we can have subtract and add by themselves, but you get into the situation where you start to ask, like, well, subtract what? Or add what? We're just assuming that that means that we want to add or subtract numbers, but we don't really know that. And so one of the things that you can do, and we haven't given this a name yet. So this is known as defining methods. So whenever you're reading some tutorials or some other code, somebody might say something to the effect of, okay, well, we're going to call the subtract method, or we're going to call the add method. So when they say that, what they're basically saying is we're going to call the add function defined on some object. So in this case, we're going to call the subtract method of the calculator object. So that's the only difference. So subtract is still a function, but because we've assigned it to an object, we're going to refer to it as a method. So it's just a way to be a little more specific about, well, where is this thing actually defined, or why is it defined there? So whenever you hear that word, that's what's going on there. But the point of this is mostly for organization. So it allows you to have slightly tidier code and get you into a position where you know, well, what is this related to? And it also helps to hint at things. So not necessarily with your own stuff. Sometimes it helps with your own stuff when you write a piece of software and then you come back to it 6 months or a year or even longer later. It helps you to kind of understand what you were doing. But if you're consuming somebody else's code, it can be really helpful, because here, if we were to write a JavaScript library and distribute it to the public, and we called the library calculator, it's like, well, that name in itself is already telling developers, well, oh, if this is a calculator, then it should be able to add, should be able to subtract, might even be able to divide. But what we're doing is we're just kind of hinting back to ourselves and other developers what this thing might do or how this is related to other pieces, as opposed to just having something kind of sit alone by itself. And arguably, this is my personal opinion, but I think this looks gorgeous. I don't know why, but this is like a little bit of art. It just looks kind of cool, and it's fun to be able to write code like this. I don't know why. That's pretty geeky, but I do like it, and I think it's a really valuable thing to understand. So one more thing to wrap this up is this idea of composition. So you might have heard of function composition or functional composition before, but not really understood what it meant. And I can give you kind of a cool version of this really quickly. So what I'm going to do is I'm going to replace this 1 with this. I'm going to say 1, 5. And so what we notice is that code works. So we saw not a number. Let's make sure this isn't confusing. So I'm going to reevaluate this. So we get a 3. And so if we look at this code, so let's say, so we're console logging all of this, and the actual code that we're evaluating is this. But notice, we got a 3 back, even though the first argument we passed to subtract was a call to another function. Why is that? Why did this work? So what's happening here is we're composing together multiple functions. So composing means literally passing other functions to other functions to get some sort of combined result. So in this case, what's happening is JavaScript is saying, okay, you're passing a call to calculator.add for 1 and 5. So let me go ahead and take care of that first, and we can expect this to get back 6. And then it's going to say, okay, now that I've done that, you want me to subtract whatever's passed in the first position from the second position. So, well, I evaluated this to be 6, so that's going to be passed as the first value to subtract, and then I'm going to take this 3. So I'm going to say 6 minus 3, and then that gives us 3. And so this is a very simple example, but this is function composition. So we're able to combine functions with other functions to produce a much bigger result. And so the implications for this are honestly quite insane. Some of the stuff that I've been able to write just using function composition is crazy. It can allow you to do a lot of really neat stuff, and it allows you to do things like a good example that I have in mind is if you're building something like a shopping cart and you need to say, okay, add these items up and then add this discount percentage and then do this and then divide this and then it has to be transformed in this way. Writing all of that by hand and doing something like this. So technically, just to show you an example, we could do this. We could say, we'll just call it, I don't know, subtotal equals calculator.add 1 and 5. And then we'll say total equals, and we'll say calculator.subtract total from 3. So I don't know why we're subtracting 3 there, but hopefully this will make some sense. So let's actually go ahead and comment that out. And then I'm going to say console.log total. Let's give you some room here so we can see this. Is it going to do it? Did I spell something wrong? Calculator dot subtract total 3. Cannot access total before initial. Oh, duh, because it's subtotal. There you go. So even experienced programmers make mistakes, kids. So what we just did is we said, okay, calculator.add 1 and 5, and we got the result of that and stored it in this variable subtotal. And then we said, okay, now run calculator.subtract, passing subtotal in, and then pass 3 in. And so we get that back as our total. So we get the same exact result as this code, but notice that we had to put it on separate lines. And so while sometimes that can improve clarity and improve structure and just make it easier to understand stuff, sometimes it does help to just be able to pass a function result in automatically like this, and it does make you feel kind of like a super hacker or something when you do stuff like that, because it just looks cool. So the point here is that we can do the same things just in different ways, but it's good to know about function composition because that can really change how you do stuff and really improve the just the power of your code and the things that you build with JavaScript. So I think that's going to wrap it up here. I know that was a lot of stuff, so definitely go back through this video and definitely check out this post on the blog, because this will give you everything and then some that this video didn't, and vice versa. So hopefully both of those will kind of balance out something that I missed in this video versus the blog post. But that's the basic idea of functions in JavaScript. We haven't covered the absolute nth degree of detail, but that's going to get you started, and it's going to get you to a position where you can start to build some really like rudimentary applications or code with JavaScript and see some actual results, because now you know about the two fundamental building blocks, I would say. So variables and functions. And so with those two, you can do some really, really cool stuff with JavaScript. So one word of wisdom is something that I've learned as I've started to write more and more code. And I guess I learned this years ago now, but it still feels like the beginning in a lot of ways. One of the things that I learned was to limit the size of your functions. So up here, we'll notice that these functions are very tidy. But I mean, just to make the point, technically this code won't work, but hopefully it'll make the point here. I resize my window instead of doing what I wanted. What am I trying to do here? Let's do this. So the point I was going to make is if I just keep pasting stuff in here. So this won't work. You don't return more than once. But the point being that the number of lines of code versus the number of lines of code here, just on a purely visual basis, this is automatically a little harder to understand than this because there's more stuff to consider. So one of the things that I really recommend is learning to extract code out of functions. And I learned this from an older programmer who's been doing this way longer than I have, named Uncle Bob Martin. And he has this phrase that he likes to use, which is extract until you drop. And so what he's talking about with that is when you're writing functions, you want to keep your functions as small as possible. So I say that it's usually like no more than like 10 lines before it gets really confusing and you can start to get effects that you don't really expect. So when I say extract, what I mean is taking logic that one piece of code is doing and extracting it into another function. So literally, when you have too much going on, typically that means that some of that code, so we'll say these 3 lines are doing something, we can move those into another function and then call that function instead. Again, using something like composition, so that way our code is easier to read, it's easier to maintain, and if something breaks, it's a heck of a lot easier to fix. So highly recommend that if you're just getting started out. That's something I wish somebody would have told me early on, because it would have saved me and a lot of the stuff I was building a lot of headaches. So I think that's going to wrap it up for this episode of Feature Fundamentals. If you haven't already, make sure to go ahead and hit the subscribe button down below and then hit the bell right next to it. So that way you're going to get notifications as soon as these are released. And again, Feature Fundamentals are coming out every Friday, and we're going to cover everything from the basics of JavaScript here all the way up to building a full-blown application using JavaScript. So it's going to take us some time, but we're going to work through it. And hopefully, if you're watching these now, you'll kind of keep up with the series if you're learning JavaScript. But if you're coming back to these from the future and you're kind of watching them, there's plenty of content here for you to kind of work through and get your bearings as far as JavaScript is concerned. So I think that's going to wrap it up here for me, folks. Thanks for watching, and we will see you next week for another Feature Fundamentals.